So the next concept that we're going to take a look at is arrays, which will lead naturally into the idea of loops as well. So we'll discuss both inside of this video. The idea of an array is that when we take a look at these basic variables that we have, we can store a single value inside of the variable. But oftentimes we have data that appears in list style. So there's maybe many different values that are associated with a single idea. So for example, you could have a situation where you are teaching a class, and inside of that class, each student may have a grade. So to describe the grade of each student, it wouldn't make sense to have a variable for every single student because for one, the number of students could change. And for two, we could have hundreds of students in a class, which means that we would have to have hundreds of variables, which would be unmaintainable to take a long time to type, right? So to solve for that kind of problem, what we do instead is we create something called an array. So we declare int grades, we'll call it, and then we simply put a little brace bracket like this, or sorry, like rectangular bracket like this. And inside of the rectangular brackets, we say how many grades there are going to be. So for my example, we'll just say that there's 3 different grades that we may have. Now we can declare the grades here by putting an equal sign and then putting the list initializer and placing the values for each of the different grades. So if there's 3 different grades, we'd have 3 different values, right? So maybe, we would have 80, 90, 95, right? So in this case, we would have what's called an array of grades. So basically each of these different grade values is stored inside of this single variable here. If I want to reference a particular one, I simply say that I want to get the grades and I specify the specific one that I want to get. So this one at the first index here would be at index 0. So these are 0 index, so this is 0. This one right here would be at index 1. And this one right here would be at index 2, right? So if I want to access a particular grade, I simply just say which one I want to access, and that allows me to do so. So just to sort of show you that idea, right, we could just go ahead and print this out. So if I print out grades at 1, what you'll see is that we will get the grade that corresponds with entry 1 in this array. So it'd be this value right here, 90. Let me show you that that is actually the case. Compile this, we run it, we see that we do get the value 90. So that is actually the case that we are getting this value right here. So that shows you how you can generally access values inside of the array. Now, although I put a size here, I don't necessarily need to do that. I can actually remove the size and allow the compiler to infer, based on what values I provide here, what the size of this array is going to be. Generally, best convention is to provide it, though, just to make sure that we are keeping consistent in the values that we're declaring and the sizes of our arrays. Just helps to prevent any sort of errors. Now, in addition to this, we also don't even need to provide these initial values. We could just do something like this. Now, what we could do is we can assign values to each of the entries in the array by doing something like this. We could say grades at 0 equals a value. So I could say equals 80, just to keep it the same as before. 1 would be 85, and then grades at 2 would be equal to 90. Do you see how this idea basically mimics that same notation where we had the 80, 85, and 90? I've just written it out so that this is at index 0, this here is at index 1, and this here is at index 2. Now, this sort of idea is helpful for situations where we don't necessarily know the values that we're going to be placing in this array until we are, later down in the program, maybe we retrieve it from some third-party source or something like this. So this is the idea of being able to work with arrays. Now, what's interesting about arrays is that they bring up another sort of problem that we have in programming, and that's the fact that how do I effectively work with all of these different entries? So in the case where we have, say, 3 entries, we want to print all of those entries onto the screen. Well, it's relatively easy to do so, right? Using what we have right now, we could do grades at 0. I could copy this and do grades at 1, and then I could copy it again and say grades at 2, and we're done, right? So this would work effectively well for us to be able to print out those values. However, if I had, say, 100 grades instead, again, we run into that same sort of problem where, typing out 100 print statements is going to be very tedious. So instead, what we're going to do is we are going to use an idea known as loops. Loops allow us to repeat a set number of instructions a set number of times. So for example, the first type of loop that we could take a look at is what's known as a for loop. A for loop is going to repeat a set of instructions a specific number of times. So what I do is I say for, and I declare what's called, I'll call it a counter. It basically keeps track of how many times we've done the loop. And it's an integer value typically, and we set it equal to usually 0, not always, but in this case we'll set it equal to 0. And I say how much I want to repeat my condition. So I want to repeat it while I is, say, less than 2. And on every single iteration of this loop, I'm going to take I, and I'm going to increment it by 1. I plus plus simply just means that we're going to take the value of I, and we're going to add 1 to it. Okay? And then what I'm going to do is I'm going to place this instruction inside of here. And I just want you to see what ends up happening when we do this, okay? When I do this loop, notice I print out 80 twice. What happened was I started at 0, and it went through and it did this print, and then it comes back up and it increments I by 1, based on this right here. So I would now be equal to 1. It would print this out again. And then when it comes back up here again, I increments once more, and I is now equal to 2, which is not less than 2. Which means that this no longer proceeds. The loop ends, and we continue on in our program. So that gives you some intuition behind the idea of loops. Now, we could do some interesting things with this. Since this value of I changes as we move through the list, it starts at 0, then it goes to the value 1, and it goes to the value of 2, we could change this 0 here to be I. What would happen is, on the first iteration, I would be equal to 0, so it would print out this value at 0. The next iteration, I would be equal to 1, so it would print out this value at 1. And then this ends at 2, so it wouldn't print anything further from there. Let me show you that that is the case. Compile this, we run it. Do you see that we get 80, then we get 85. So you can see that I actually is increasing each time. And in turn, that allows us to access different elements inside of our array. Now, if I wanted to get all the elements in this array, I would do less than 3, right? That way it actually increments through all of the elements. And you can see that we can print out all of the elements in our array without having to repeat that print statement multiple times. And that's really the power of our loop. Now, there's a few interesting things that we should discuss. So one of those is, what if we didn't know what the size of this array was? So we didn't know necessarily that it was going to be equal to 3. How do we get the size? Well, there's a few different ideas that we would need to discuss for this. We can get the size of an array using the size of function. This will tell us the size of the array, and we saw this when we were talking about types. But you'll see that something interesting happens when we do this. When we do this, we get a value of 12 as a result, which may at first seem odd because we only have 3 entries in our array, but we have to remember what the size of operator does. It tells us the size of something in bytes, right? So this tells us that this array is 12 bytes, which makes sense because it's 3 integers, and integer is 4 bytes. That gives us 12 as a total. But then the question is, how do we get how many elements there are? Well, we can take this size and divide it by the size of an integer, right? Since it's an array of integers, if we divide this size by the size of the type integer, that would give us the number of elements. So in this case, the number of elements would be 3. And you can see that that does actually work. The main thing to keep in mind here is that when you do this, this second size of needs to match this type here. Make sure to do that. Some people will just always use size of int, and it will give you wrong results if your array is not an integer. So just keep that in mind there. So with this idea, what we could do is we could actually modify our for loop. Rather than doing less than 3, we could do less than size of grades divided by size of int. This would give us the total number of elements inside of our array, right? So this will work to be able to iterate through this array no matter what the size of the array is. So if like later on I decided that I wanted to change this to be like a size of 5 instead, this code would still work for us, right? So we can see generally that when we run this, it does indeed give us the exact same result. So that's how we can get that size a bit more dynamically. So with that, you now understand a lot more about arrays and the ideas of looping and finding the sizes of arrays. We'll finish off here just by discussing a few other types of loops that do exist inside of C++. So this was a for loop. A for loop is a really basic kind of loop. It just starts at a particular value, it ends at a particular value, and it increments by a set amount each time. There's a second kind of loop that's a bit more general, known as a while loop. A while loop simply repeats instructions while the condition inside of the brackets is true. Once that condition is false, the loop stops. So what we could do is we could say, we could declare an int I that was equal to 0, And then we could say while the I is less than the size of grades divided by the size of int. And then repeat the instructions inside of here the same way that we were doing. So we could do like another cout of, grades at I, right? Something like this. And this should give us a similar type of idea to our for loop, right? The main difference is that this while gives us a bit more freedom in terms of specifying our condition for our loop. Now there's one really important detail here. This loop will continue while I is less than the size of grades divided by the size of int. That means that I needs to change inside of this loop. Otherwise, the condition will always be true and it will loop forever, right? So to do that, we could just do I equals I plus 1. Or if you want to use a different kind of syntax, you could do I plus plus, or you could do I plus equals 1. All of these will just add 1 to I. So it's really up to personal preference. I think I plus plus is the most typical one that I would see, so this would be the idea here. So this is the idea of a while loop. Again, this condition could be anything from the conditions that we talked about, something that could be either true or false, and that's going to allow us to loop for a specified condition. Now, a few other sort of variations on this, we can change this while loop up slightly to create what's called a do-while loop. What a do-while loop is, it does something, again, while a condition is, true, right? So we can move, this condition over here, get the same sort of result, with one small difference. That difference is that this while loop checks the condition first and then goes into the loop. The do-while loop checks the condition after. So it checks it after the loop actually runs. So the idea is that this do-while loop will always run at least once because it will do what's inside of this loop and then check the condition. Whereas the while loop will run only if the condition is true. So it checks the condition first before it enters into the loop. So that's the difference between these two. Aside from that, they run the exact same way in terms of checking this condition and continuing to loop while this condition is true. So that's the idea of while loops and do-while loops. One final kind of loop that I'll discuss here is a for each loop, which is a modified version of the for loop, which works really nicely for the arrays that we're talking about here. So what we could do is we can loop for each of the elements inside of the array. The way that we do that is we create a variable, which is going to match the type of the array, and we put a colon, and then we put the array. Or in this case, my array is called grades. So what this will do is it will set I equal to each of the different grades inside of this array, and then allow us to do something with them. So you'll see here that if I do a cout with I, what it will do is it'll print out the actual value in the array. So we can take a look at this here. When I do this, do you see that it prints out each of the values inside of that array, right? So that's because I takes on the value of each element in the array, and it just goes through all of the different elements in the array until it reaches the end of the array itself. This lets us loop through an array easily without having to keep track of like an index that we're currently at in that array, using that like I equals 0 type of idea. So this is ideal for situations where you would want to just loop through the different items that exist inside of your array, whereas a for loop works better if you want to also know where that item is in the array. So for instance, since we have that I equals 0, I is less than, the size of the array, that I value keeps track of where we are in the array. So if we wanted to say change values in the array or do something with that particular index, that's where a for loop comes in more handy. A while loop is best for situations where your condition is more complex. So maybe we want to loop while, the cin is not failing, right? So we want to continue to take input until they provide something that doesn't fail the cin, right? That could be an example of using a while loop. It's more of like a condition that wouldn't work well with like incrementing through a for loop, this type of idea. So this gives you more of an idea of arrays as well as loops inside of C++. So thanks so much for watching, and I'll see you in the next video.